Good evening, my name is Edward Washroom. I'm here this evening to expose one important techniques, one important secret in estimation procedures. I'm going to adopt a schematic diagram that was developed by Mohammed Saad, Shipra University of Lahore in Pakistan. I'm going to adopt this schematic diagram to ease my explanation of the statistical model or how to select the approach for econometric estimations or analysis after your unit truth has been done properly. Recall in my last class where I taught you how unit truths are supposed to be done. I also told you that the unit truth text will have three concessions or three outcomes. The unit truth at level, after first differencing, and after second differencing. And I've told you how to interpret the unit truth results at level, at first difference, and at second differencing. And recall that I also told you that after your unit truth text, it could be that all the variables became stationary at level. It could also be that some became stationary after they were subjected to first differencing or second differencing. But whichever situation you find yourself in your research work, there is always a method that you will use for the estimation. So this evening we are going to expose to you all the relevant method in time series studies that you are expected to use for your study. So whenever you are doing a study and you find out that all your time series data after being subjected to a stationarity text using any versions of the unit truth testing procedure, and you find out that they all became stationary at level. Remember, I taught you last week that to decide or to take decision concerning the stationarity condition of a unit truth text, you are expected to actually determine if the variable has trend or intersect or trend alone. And if you are reading the unit truth text, most of the time you may decide to check through the probability value, or you decide to use the t-statistics. And using the probability value, I told you that whenever time the p-value of your unit truth result is less than the 5% threshold, it then means that particular variable do not have a unit truth. And when a variable do not have a unit truth at level, it implies that the variable is reverting to its mean values, or that the variable is stationary at level. So whenever time you find out that all your variables in your study are all stationary at level, the best approach, the best method of estimation, the best analysis you are expected to do is ordinary least square, which is long run regression. Whenever time all your series became stationary at level, do not bother yourself to look for any sophisticated means or approach. Just conduct a long run regression. And a long run regression is the simplest OLX estimation procedure that you can do. And interpretations should be aligned with the ceteris paribus assumptions. So whenever time you find out that all your series became stationary at level, do not worry yourself. Perform an OLX, interpret results, make your recommendations, and proceed. It will be accepted. But there is also a scenario wherein you find out at all the time series data is subjected to a unit truth procedure became stationary after first differencing. All of them became stationary after first differencing. Whenever time you find out that all of them became stationary after first differencing, the best thing to do is to conduct a co-integration test. And the best co-integration test you are expected to conduct is what they call the Johansen co-integration test. Whenever time all your time series data became stationary after first deferencing, you are expected to conduct Johansen co-integration test. And the Johansen co-integration framework will expose you to 4 concessions or 4 outcomes. The first outcome is that there may be no co-integrating relationship among all the hypotheses or the relationship you have presented. That is the first outcome. The second outcome is that there may be complete co-integration amongst all the variables or among all the relationship you are testing. Then the third concession or the third result could be that there may be at least one co-integrating relationship among all the variables or the relationship you are testing. Then the fourth one could be there may be more than one co-integrating relationship among the variables you are testing. If the first condition holds, wherein there is no co-integrating relationship among the relationship you have tested, then the best thing to perform is the VAR, the unrestricted VAR model. The unrestricted VAR model is conducted or is used to estimate your model, to estimate your work whenever time the Johansen co-integration relationship or Johansen co-integration result tells you that there is no outstanding relationship among the time series data in your studies. But whenever time there is or there are more than one or at least one co-integrating relationship in your model, that means that you have to go to error correction models. The error correction models can also be split into the ECM and the VECM. Whenever time you have more than one co-integrating relationship or more than one endogenous model, it is expected that you conduct a vector error correction mechanism. But whenever time you have at least one endogenous relationship, you conduct the error correction mechanism. But there is also a situation whereby all your relationships are co-integrated. If you find yourself in such a situation where all hypothesis tested shows the presence of a co-integrating relationship in the model, then you have to perform what they call dynamic ordinary least square estimation. So DOL is an estimation procedure that makes use of lag and lead. So given the fact that you have such a situation, the best estimation procedure to use is the dynamic ordinary least square estimation. So back to the unrestricted VAR model. The unrestricted VAR model, which I said previously, is applicable whenever you have no co-integrating relationship in the Johansen co-integration. Recall that when we are going to be discussing the Johansen framework, we are going to make reference or make inferences from the trace statistics and the mass against statistics. And whenever time decisions of the mass against statistics conflicts with the decision of the trace statistics, the trace statistics takes preeminence. So under the unrestricted VAR model, we are going to also make use of 2 instruments. We are going to make use of the variance decomposition functions and the impulse response functions to determine the shocks and innovation inherent in the file system. Whereas in the error correction model, we are going to dwell with the ECM and the VECM. And under this ECM, we are going to first of all estimate an over-parameterized error correction mechanism before we now estimate an encompassing a parsimonious encompassing error correction ECM. And the major reason why the parsimonious encompassing error correction mechanism will be accepted or will be used or will take preeminence over the over-parameterized ECM is whenever time or when the adjusted arrow square of the parsimonious encompassing ECM is greater than the adjusted arrow square of the over-parameterized ECM. So the selection of the best ECM is based on the value of the adjusted arrow square. Note that the ECM value must be negative, less than unity, and statistically significant for it to be accepted, irrespective of the value of the error correction of the adjusted R square. Then, secondly, the VERKIM or the vector error correction model, which is another part of the error correction model, entails a situation where virtually the system some of the variables are endogenous in nature. But however, when we come to the ECM explanation, we'll deal with it appropriately. So there is also a scenario whereby the unit root text conducted shows a mixture of some variables became stationary at level while others became stationary after first differencing. And that means that we have a variable of different order of integration. And whenever time you are caught in that web, the best estimation procedure is the ARODL estimation procedure. The ARODL estimation procedure was put in place by Pearson and Shine and Smith in 2001 as a dynamic modeling procedure that takes care of situation wherein time series data became stationary at level and after first difference, provided that the dependent variable is integrated at other one. That's ARODL estimation. Then we also have a scenario, a situation whereby the series or the time series data used for the study became stationary after first difference and after second difference. And at that level, the best estimation procedure is autoregressive models. The word autoregressive model implies that the dependent variable will also, the last value of the dependent variable will be an independent variable in the same model. When we come to autoregressive model, we also do justice to that. The last estimation procedure we are going to look into this evening is what we call the Tuda-Yamamoto 1995 estimation procedure. Tuda in their 1995 paper made use of time series data that were stationary at level, stationary after first differencing, and stationary after second differencing. So Tuda-Yamamoto is an augmented VAR statistics that gives us result that looks like a chi-square distribution. So when we come to this Tuda-Yamamoto, which is unlike a Granger causality test, but it's not a Granger causality test. We call it is a non-Granger causality test. And the formula for Tuda-Yamamoto, according to references used in this research work, will also be made open when we are dealing with Tuda-Yamamoto estimation procedure. So basically, in time series study, these are what we are supposed to do, or how we are expected to select our approaches or method for estimations. And once this is done, we will not have problem doing what is not supposed to be done, like what we find in most research work. So, brothers, thank you for staying tuned to this channel. We are going to bring to you more sophisticated means of doing things, and thank you and God bless you.